Alrighty, folks. When we look at question number 6, I'm going to start by cubing the question. It says write an equation of a line that is a perpendicular bisector of the line segment having endpoints 3, negative 1 and 3, 5. Um, Here, the directive is write an equation of the line. The actual verb here is write, and use of the grid is optional, kind of unnecessary to know. Um, so what I'm going to first do is label the points x1, y1, and x2, y2. Since I'm trying to find a perpendicular bisector, I first need to find the slope between these points. I'm also going to go ahead and just plot them on the grid. So 3, negative 1 is at 1, 2, 3, negative 1. And also 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. So what I'm noticing is that the segment is a vertical segment. I'm still going to use the slope formula to find the slope of this. So the slope formula is y2 minus y1 over x2 minus x1. In this case, that gives me 5 minus a negative 1 over 3 minus 3. And this ultimately gives me 6 over 0. Because I'm trying to find a perpendicular bisector, that means now that I know the slope that connects these 2 points, I need to find a perpendicular slope. I know that a perpendicular slope is an opposite reciprocal of the given slope, so that would become negative 0 over 6, which is still just equal to 0 at the end of the day. Now, what I need to do is I need to find the midpoint between these 2 points, because it's a perpendicular bisector, and a bisector goes through the midpoint of the segment. So the midpoint formula is m parentheses x comma y is equal to x1 plus x2 over 2 comma y1 plus y2 over 2. In this problem, for these values, x1 is 3 plus x2, which is 3 over 2, comma y1 is negative 1 plus 5 over 2. This ultimately gives me the point 3, comma 2. So this is where the midpoint is, at 3, comma 2. I'm just going to double check with my grid. So at 3, so 1, 2, 3, comma 2, that point does appear to be the midpoint of this segment just by looking at it, and I reconfirmed algebraically. So now I need to find the equation of the line. The equation is going to take the form y equals mx plus b. I'm going to substitute in the perpendicular slope and also the midpoint of the segment. When I plug these two values into this equation, this gives me 2 is equal to 0 times 3 plus b. What this means is 2 is equal to 0 plus b, which means 2 is equal to b. So I'm going to rewrite this equation using the perpendicular slope and now my y-intercept, and I get y is equal to 0x plus 2, which can actually just be simplified to y equals 2. which makes sense because y equals 2 is a horizontal line that goes through the y value of 2. And these two lines are indeed perpendicular. So I have now found the equation of a perpendicular bisector that goes through these endpoints. And that concludes question number 6.